This is Samaje's Easy World Science Channel. In this live stream, I'll be taking a look at the immediately concluded waec 2024 Alternative B practical questions. So, you're welcome to this live stream. As usual, we will feel here. The pen is there. Remember to write your name and the exam number, as usual. Over here, we'll be working with Her Majesty Easy World Science Channel. So center number should be +234 7065166217. Candidate's number, anything can serve. Okay, so we'll take a look at the thing briefly. I'll be very quick. Remember to ask your questions in the comment box or in the comment section, of course. Then you're also advised to write your name on each page. You go through them. Remember, most times this is for examiners only, not for the students, of course. So we go and I'll handle question 1 and 3, that's titration, and then the number 3 question. Then first of all, it's very important for us to see how my predicted questions falls in line with what finally came up here. The question for number 1 says D contains 6.30 gram of HNO3 in 500 cm cube of solution. E was prepared by dissolving 8.20 grams of washing soda crystal Na2CO3.XH2O in 250 cm cube of distilled water. Then they say put D in a, after everything, make a table, and then the first question was to write the balanced chemical equation, followed by calculation of concentration of E in mole per dm cube, and then by finding the value of X in Na2CO3. So this is it. Now let's go to my own predicted question. See here, number 2. Say what it means. It was almost the same. They used 500 cm cube. I used 500 also. So this is very much correct. It is rhyming by the grace of God. Thank you for following up. We will never make you lose. So you see the likely question. I have the 4 likely question, but now number 2 entered. I've never missed at all. So they brought the hydrated form, even though they told teachers to prepare the anhydrous from their instruction form. But they later came up with the hydrated, which is very much possible because you use math to put it in reality. And then look at the equation of the reaction, which became question number 1. Okay, then from your results and information provided, calculate the concentration of the mole per dm cube. You must calculate it before you could forge ahead with the question they gave us. Concentration of anhydrous, that's the concentration of E mole per dm cube, and value of X. So you see how much we were rhyming. So we have to go back and continue. First of all, here we are required to make a table. The unit table will give you a good mark, of course. So you endeavor to make your unit table, follow the rule, put your units, and also try to obey the significant figure. That's 3 significant figures. So here in making my table, the basic informations are actually we have to write burette readings, and then followed by rough titer, rough, followed by first, second, and third. We rule them separately. Okay, then Then don't forget that on top of your table you have to indicate the volume of pipette used. Volume of pipette used, write it 25.00 cm cube. That's a special mark on this one. Then here we have final. You indicate that is in cm cube necessary. You have your initial. You also indicate that it is in cm cube. And you have volume of D, because D is what is in the red, used. Okay, so we have made our table. There are lines already there. If you like, you can run it more. So I'm going to use what I got in my own titration from the instruction form. You record the initial before final, 0.00. Then the final from the one I did was all of them were actually concordant. I got 24.70. Remember, this is not the best. It depends on the percentage concentration of the HNO3 you have. So the major thing is that you don't vary with your teacher. With plus or minus 0.2, you get the whole mark. But if you fail to fall within the range of your teacher, that doesn't mean you fail the whole question. Your solvings will still get you mark. Only that your VA, you'll be required to be awarded 0 at that point if you vary with more than 0.4 or 0.3 away from what your teacher recorded. Okay, my first, I got 26.70, and then why am I writing 26? 24.60, sorry, 0.00. And if you minus here, it will be this way. Then 24.70, 0.00 in real life from the one I got from the lab. Then 24.70. The third titer I got 24.60 again. So in this case, it becomes obvious now. We can now make our VA. So you tell the examiner they are all concordant. If you like, you use the whole 3 or you use 2. So we can decide that our VD this time around, you say first plus second plus third all over 3, and VD should now imply 24.60 plus 24.70 plus 24.60 divided by 3. We will try to visit calculator. Let's see. Okay. So 24.6 plus 24.6 plus 24.7 is 73.9. So 73.9 divided by 3, we have 24.63, 633, 24.63 cm cube. Answer. So we are done with this page. We go to the next. Okay, we go down. I'm going down. We have this now. They say write a balanced chemical equation for the reaction. Remember, you must include that water of crystallization. because they say for the reaction this was what is reacting, so don't exclude that X. So your job is to write the reactant is HNO3, that's the acid. Okay. Okay, the acid is HNO3. HNO3 plus Na2CO3 dot XH2O to give you definitely there will be sodium nitrate plus water plus CO2. Then because hydrogen is 2 here and is 1 here, we put 2 here. States of matter is necessary: aqueous, 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 liquid, and gas. These are necessary, of course. Now you need to balance, because they say balanced. I've put 2 here, but I've not compensated for the water. Let's assume, if you want to balance this equation, see what we're going to do. You assume any number to be here. If 3 is x, if x happen to be 3, or let's say x is 10, as we know, then remember that 10, if you put 10 here, it means that hydrogen is now 2 times 10, which is 20, plus the 2 here, 22. So what number will you multiply by 2 to get 22 over here, which is 11? And that means if x is 10, how do you get 11 from x? By saying x plus 1. So what it will now be is x plus 1 H2O plus CO2. That's the correct thing you need to write for them. So the product will be x, say bracket x plus 1 bracket H2O plus CO2, and then the equation is balanced. So you are done with this number. We go to the next page, of course. Remember to ask your questions where necessary. I can still see the screen. Sorry, I started this first time. Matthew, I can't see you again. There was a little trouble. I have to delete the first live stream entirely. Okay, they say from your results and the information given, calculate the concentration of E in mole per dm cube. Remember, the one taking part in neutralization reaction is the anhydrous one. Water cannot neutralize water. Water is already neutral. So the water of crystallization cannot contribute in the endpoint. It is the pure sodium anhydrous sodium carbonate that will contribute in determining the endpoint. So over here, we actually we need to use the formula that we need to use here is CAVA, but unfortunately we are dealing with D and E. So why bringing in A? That is to correct you that A that you see normally doesn't really mean acid. A is just a way of identifying a specimen. So because we are using D, now the molarity of D times the volume of D all over molarity of E times the volume of E equal to the mole ratio, if you like, mole ratio of D all over mole ratio of E. Now, the thing there is that we are required to pass through something. We need to get our CD first because it wasn't given. CD is now what first? We need to tell the examiner that D is what? From the question, they told us that D has in 500 cm cube that D contained 6.3 grams of HNO3. Therefore, 1000 cm cube will contain what? If not in 1000, find out the one in 1000. That's how to do it. Will contain X. You cross multiply. When you cross multiply, what do we have? 500X is equal to 6.3 times 1000. After everything, you will get 12.6, but let us just follow it in a tortuous way. So x over here automatically becomes 6.3 times 1000 should be 6300, if I am correct. Yes, 6300 divided by 500. So from the calculator department, to be sure, this is what I'll be suffering. Is equal to 12.6. So we have that it is in the mass conc is 12.6 gram per dm cube, using the formula which says that mole per dm cube is equal to gram per dm cube all over gram per mole. So what's the molar mass of the compound? The molar mass, gram per mole of HNO3, is equal to 63. That's the molar mass. And we have already gotten 12 as the gram per dm cube. Therefore, the molarity, mole per dm cube, should now be equal to 12.6 all over 63, which will give us 0.2. So 12.6 divided by 63 is equal to 0.2. So the strength, the CD now is 0.2. Our CD is 0.2. We can now come here and make CE the subject of the formula. So make subject of the formula before you substitute. From the relation here, CE is equal to CD VD times NE all over VE times ND. Now you can now fill in your values. From that you can get your answer. Our CD is now what? 0.2 times the VD is the, we have calculated that initially, we got 24.63. You can use any value you get in your school, but it's not going to be below it shouldn't be below 20, and it shouldn't be above 30 either. So 24.63, if I can recall well, yes, times NE is the mole ratio of the base, that's the Na2 carbonate. From the mole ratio, it was only one mole that we put under it, therefore it's going to be 1. So times 1 all over VE is the volume of pipette used, which is 25, times 2, that's the mole ratio of the acid. Remember when we balanced it? So from the calculator department, we will have that 0.2 times 24 is going to be, actually it's going to be 2.4 times 2, which will give us around 8 point some 5 point something. But let me go here and times it. 0.2 times 24.63 the other one is 1, which is the same thing. So we have 4.9260 divided by 50, of course. 4.926 divided by 50, because 25 times 2 is 50, which will give us, from the calculator department, we say divide by 50, which is giving us 0.098. 0.098, approximately 0.1, 0.0985. So CE is equal to 0.0985. Maybe we can use three significant figure to keep it that way. Mole, remember to put unit after each answer. A DMQ is needed. We now move on. This I say, what is the value of X in Na2 CO3 dot XH2O. This place will require us to convert this mole to mass. You need to convert the molarity of Ce to mass for you to know this. But first of all, the formula we need to use here is mass of water over mass of anhydrous, mass of water all over mass of anhydrous is equal to mass of water given or obtained all over mass of anhydrous given or obtained. So what do we mean here? We are taking this compound now. Over here, this is just the formula we need, but we need to divide this sheet so that the calculation will enter well. Over here is the compound. So we are looking at dividing this into two. This is anhydrous, then this is mass of water. Where hydrogen is 1 and oxygen is 16, this means the molar mass of water is 18. So this implies, rewriting this, we now have that XH2O over what? Na2CO3 is also equal to the mass of water. I'm repeating the same thing here, so because of time, is also equal to mass of water all over mass of anhydrous. This time around, given this MW and MA is not a universal symbol, is what I'm using just to move on fast. So we are going to convert these things to mass first. So molar mass of water is 18 because hydrogen is 1. 1 times 2 is 2 plus 16 times 1, which is 18. Molar mass of sodium triisocarbonate 4 is 106. Therefore, at least we have gotten now that 18x is equal to 106, which is equal to, we will now go and find the mass of water given or mass of water obtained all over mass of the anhydrous. Which one is the anhydrous class? Please, the anhydrous means the one that participated in this. This is the molarity of the anhydrous. So from the molarity of the anhydrous, you will get the mass of the anhydrous salt. The sense there is that out of this compound provided, like in the 8.2 gram they told us in the question, is only the mass of this that will neutralize HNO3. Water cannot neutralize HNO3 because water is already neutral. It's not a base. This is the base aspect. So this is the only one that will react. Therefore, whatever that we calculated that reacted with HNO3 is automatically for this Na2CO3 only, not for water. So this implies that we will go back to convert our 0.0985 to molarity. Therefore, 0.0 Ce is equal to 0.0985. So if you convert to mass, you just multiply by the molar mass so that gram per dm cube of it is equal to 0.0985 times the molarity, which is 106. The molarity from the calculator department. Okay. 0.0985 times 106 is 10.441, believing I'm correct in my calculations here. 0.0985. But what if I've made it 0.1? What if I approximated to 0.1? It will be 10.6 exactly. But here it's giving us 10.448. Okay. We now go back, this is 0.0985 times the molar mass, which is giving us 10 point. Let me check again. 10.44. 10.44 gram per dm cube, of course. Then this is the mass of the anhydrous. Actually, that's the mass that is actually reacting, provided our calculations are not faulty. Thank you for visiting. I plead you like and share this video. You are just there watching, no share, no like. Well, that's great having you. Thank you for supporting me grow by not liking. At least you are there watching. So I cannot do without you. Much love from me to you. Give this video thumbs up and share. Okay, then your contributions are welcome in the comment box. If I contradict what you think is right, I welcome your criticism. Two good heads are better than one. Okay, but as we move on, I think I am in order so far. We have to now say that the mass of anhydrous is 10.44 grams. Now you go back to the question about E. E, they told us, contain 8.20 gram in 250 cm cube. Therefore, we want to find out the amount that will be in 1000. So 1000 will contain X. After everything, it should be 8.2 times 4 to save time. 8.2 times 4 is 32.8. So 32.8 grams per dm cube is the mass of hydrated. Therefore, we are going to get our mass of water as what? Mass of water is equal to mass of hydrated minus anhydrous. What is our anhydrous? 10.44. What's hydrated? 32.8. So 32.8 grams minus 10.44 automatically gives us I hope my calculations here are correct. Yes, it is very, very correct. CDCEVE. Want to check again? CE is equal to CDVDNE for ND times VE. Yeah, it's a very correct math. So 32.8 minus 10.44 minus 10.44 is giving us 22.36. 22.36. So mass of water is 22.36 grams. Therefore, we go back here now and start fixing. We have gotten all we needed. This implies that 18x over 106 is equal to mass of water now is 22.36 all over. Mass of anhydrous, of course, is now the 10.44 in that order. You now cross multiply. You now have mathematically that 18x times 10.44 is equal to 106 times 22.36. 22.36. So 106 times 22.36 will give us what? 106 times which one are we times in here? 106 times 22.36. That's times 106, of course. It's 106. We have 2370.16, 2370.16, 2370.16, while this one is 18 times 10.4, 0.44 is 187.92, 187.92, 187.92, if I'm correct, x. So that x alone now is, divide both sides by, this is a point, 187.92 divided by 187.92. So 230, maybe divide this so that it will be easier for me. Okay. 2370.16 divide by 187.2, sorry, 187.92 is giving us 12. That's too much. Okay, it's giving us x as 12. I'll check my solvings again to check if there is any error. So x, according to what they gave us, is 12. Remember, you're allowed to get anything because they hyped the number. Okay, here say concentration of E in mole per DM cube. Our concentration, which is CE, 6.3 was in 500, so that 12 grams will be in this. Then dividing 12.6 by 63, we got 0.2 is correct. Therefore, we have now that CE equal to CD. If we cross multiply this, is very much correct. CEVE ND. So you divide VE and ND. Yeah. So far, the calculation is correct. Question is 4.926 divided by 50. Let me confirm again. 4.926 divided by 50 is 0.0985. Is in order. Okay, so we are in the same page. We are done here. Go to the next question. Over here, result analysis. I'll skip this, but it's a simple process. It's only this I that I'll still do. Well, I'll follow the steps in another video, but let me save time. This other one says an aqueous solution of a salt was added to excess sodium triazocarbonate 4 solution in a test tube. There was effervescent. The test tube became warm and white precipitate was observed. State 3 inferences that could be drawn from these observations. So what are the conclusions we are drawing? First of all, they have mentioned that the thing became warm. So at least the observation is that the reaction is exothermic. Number one, the reaction is exothermic. And again, they mentioned precipitate formed. An insoluble product was formed. An insoluble product is formed. A solution was added. So since they say was, you continue reporting was. Or you say a double decomposition occurred invariably. Then what other thing there? It also indicates that a gas is evolved. Since effervescence occurred, it also shows that a gas, or just say gas, was evolved. A gas was evolved. Yeah, I think it's correct. Why? Because of the effervescence. And then solution of salt. Aqueous solution of salt is acidic. Aqueous solution of the salt is acidic, likely. Okay, so you saying that the gas turn line water milky, okay, but they don't, you saying carbon dioxide, they didn't actually mention that. So but these are, you choose any of these three here. Then I say consider the following salts: ammonium chloride, lead 2 sulfate, ammonium hydrogen triazocarbonate 4, copper 2 triazonitrile. They say select from the list the salts which would not readily dissolve in water. Whether you try to check if there are more than one, you find the one that group them. Ammonium chloride is very soluble. All sorts of ammonium salts are all soluble in water, no exception. Then lead 2 sulfate is insoluble. It's one of the insoluble sulfates. So the one that will not dissolve in water. Every other one is soluble in water. That's the only one there. They say produces effervescence with dilute mineral acid. The one that will produce effervescence with dilute mineral acid is the bicarbonate, sodium bicarbonate, NHCO3. That's the only. Decomposes on heating, of course. The one that will decompose on heating, ammonium chloride will decompose on heating. Does it really? Yes, of course. To give this and this will decompose on heating. Even this one will decompose on heating. Copper night, all of them will decompose on heating. Decomposes on heating. I'm not sure of the sulfate, but I'm sure of 1, 2, 3. Copper nitrate decomposes on heating. So that will be NaCl. You heat it, it sublimes, although as a, because it's sublime, I don't know whether we will not use the word decompose here, though the reaction is a kind of reversible. When ammonia is heated, it will give you, my argument here now is action. If you say ammonium chloride, if you heat it, it gives you HCl and ammonia now, which will invariably give us back this. Okay, I don't know the intention here, but at least the one I'm very sure of is that the bicarbonate is decomposing, but the carbonate itself do not decompose. That's the sodium triazocarbonate 4 doesn't decompose, but the hydrogen carbonate decomposes. Copper nitrate, of course, decomposes on heating, and then possibly ammonium chloride dissolves in water to form an alkaline solution. That is where hydrolysis comes in. In practical, this is going to be ammonium chloride cannot form alkaline solution because of salt hydrolysis. It forms an acid solution because it's a salt of weak base and a strong acid. But copper nitrate will form an acid solution also. This one will not even dissolve in water at all. That's the ammonium, the lead 2 sulfates, not to talk of forming alkaline. Dissolve in water to form alkaline solution. Is this acid salt? It's an acid salt, but it forms an alkaline solution. If you dissolve this, it is the pH is about 8, and 8 is alkaline now. So though we call it acid salt, and we use this as a mild base to neutralize some acids. If you have acid spill or acid pour in the lab, this is what we use to treat it. And even if the venom is a bit acidic, you can use this. So the only correct answer here is going to be NaH, though it's an acid salt, but it forms an alkaline solution. Copper nitrate will give us acidic solution. This one doesn't dissolve at all. This one gives acidic solution because they are all sorts of strong acid and weak bases. Copper hydroxide, weak base. Ammonium hydroxide, weak base. HCl, weak strong acid. HNO3, strong acid. So it's only the practically this NaHCO3. Then sublime on heating, ammonium chloride. I just mentioned earlier, sublimes on heating. Maybe to stay on the safer side, I wouldn't know whether they will consider this one as the thing that decomposes on heating. Okay, we are done with this page. Going to the next question, probably the last for this live stream. A solution of, remember you're on with Sa Majesty Easy World Science channel, of course. Please endeavor to subscribe and share this video. We'll be having live streams, live videos, even live practicals. We had one a few days ago, I think yesterday. So please, I actually beg of you to subscribe and share. This channel is not only for exam. There are many experiments, and this one is very okay for, the experiments are okay for all levels of learning, for lovers of science at all grades. Endeavor to subscribe and share my videos. I cannot do without you, of course. Okay, now we have to take some break.
Contact Sa Majesty for laboratory equipment. Hi, I wanted to tell you that you can contact Sa Majesty for laboratory equipment and reagents. They are affordable and provide accurate results too. Sa Majesty is what only sells what he knows, and his patterns of delivery are sure and certain. Place your order today. Thanks for your patronage.
See my pet filler can also
about Sam. Wait a minute, have you heard about Sa Majesty Easy World? Well, I'm a subscriber to at Sa Majesty Easy World on YouTube, and I'm a student at University of Camerino, Italy. Sa Majesty made science so easy for me, and it took away the fear I had on chemistry and biology. Distance is not the barrier. Guys, you have to join the Easy World today at www.easyworldscience.com and on YouTube at Sa Majesty Easy World. Bye. Thank me later.
Between 50 kg of feather and 50 kg of cement, which one do you think is heavier?
Uncle, that is very simple. The 50 kg of cement
is heavier than 50 kg of feather.
Yes, sir.
Why?
Because cement is cement and feather is feather. Uncle, I've carried cement before. Obviously, it is heavier.
Okay. It's heavier even when they are 50-50?
Uncle, cement is cement. I don't need to tell you this. This question is only for idiots, and I'm not an idiot.
What if the answer says you are?
Then Uncle, I'm right and you're wrong.
So I'm the idiot here? Your teacher?
Uncle, you think I'm an imbecile. But asking this stupid question is actually hurting my dignity.
Things Sa Majesty's would have made you laugh, now let's make you learn. Remember the question said 50 kg of feather and 50 kg of cement. 50 cannot be greater than 50. And this is also true because they're in the same unit of measurement. When you're carrying 50 kg of cement, it is the same thing as carrying 50 kg of feather. They both have the same weight. Thank you for watching. Remain majestic.
Alright, you can find more of this type of video here at Sa Majesty's World. We educate, we entertain, use all means to bring knowledge to your doorstep. You could have answered that 50 kg of feather, of course, but unfortunately 50 cannot be greater than 50. Enjoy more of that even on my TikTok handle. Find more of this type and then go to our shorts. You see more of these videos there. So we have majestic periodic table for you.
Have you heard about majestic table? It was designed and recommended by Sa Majesty himself. Yes, yes. The amazing thing about the majestic periodic table is that it provides a clear and colorful classification of elements from bulk metals to metalloids to liquid metals. It also shows the boiling and melting points of all the elements. It also has the unique filling of electrons in the shells of each element.
Okay, so you order for this majestic periodic table. You can customize one for yourself. As you can see over here, they come in different forms. The majestic periodic table is highly informative in different sizes. You have the paper form, you have the sticker form, the flex for students' notes. and it's very cheap and affordable. You customize one for your school, it will bear your school name if you like, then you give it to people as a gift. So this particular table is designed to enhance the learning of science. It is highly informative, and your support and patronage is actually needed. I cannot do without you. So we go back and complete the past questions. Remember to place order. You call with the number +234 7065 177 +234 7065 As you can see there, this number, you contact us there if you need this majestic periodic table. Is highly informative, and we print it to any size. The resolution, the clarity, the colorful classification, very importantly, the configuration of all the elements are very clearly shown to you using this majestic periodic table. Of course, then before we go back, we can see amazing experiment over here where I was able to generate electricity from a chemical reaction. Of course, you see, just simple chemical reaction using amazing Daniel said I generated electricity. So you can contact me for your science projects, amazing ones that you can present, especially on your graduation day, and many of them for your research and also for production processes. You are working on industry. I handle analysis very well at all levels. Thank God I have somebody like you. Please subscribe and share. You see, I'm powering the weighing balance here with just the Daniel cell fixed together. The ones I've been watching, they have never used it to power something. It can only generate 1.1 volts, but when I use it to power bulb, it's not working, but here it's working. You can watch the video here at Sa Majesty Easy World. And then some amazing experiments over there. We have, okay, that's the little we can show for now. We go back and complete what we are doing. I think the last question is here, which says, welcome back, please. A solution of an acid was titrated with sodium hydroxide solution using methyl orange as the indicator. States 3 precautions that are necessary when carrying out such an experiment. You are just required to state precautions taken during titration. First, avoid error due to parallax while taking the burette reading. Error due to parallax, meaning try to keep your eye level with the zero level. Most times the problem students suffer is because some of you, the height to compare to the bench, the analytical bench, you might not see well. If you are viewing the burette from down above, most times it will be above zero and you think it's zero. So most times it might be below. So you are advised to do anything possible to keep your eye level to the same mark with the burette so that you take accurate reading. Then avoid air bubbles, of course. Add indicator, don't add excess indicator. Avoid titrating with broken apparatus. Then avoid the what we call you have to make your table properly, yes, of course, so that you can take accurate readings of the final and then the initial. So these are the precautions you take while doing titration. Remember not to blow off anyone remaining in the pipette after pipetting, and don't spit into the pipette if you are using mouth to pipette, of course. So with this we have come to the end of this live stream. Thanks for having someone like you. Please, I cannot do without you. Just endeavor to subscribe and share my videos. Much love from me to you. Bye for now.